The question is, use the limit definition of derivative to find derivative of f of x equal to 1 over square root of 6x plus 19 plus 19 at x equal to 5, and use derivative rule to verify your result. That's the second part. So what are the limit definitions? We have two types. One is this limit, and the other one is this limit, a plus h minus f of a over h. If I write both of them down, let's write, so those are the two limit definitions, and I'm writing limit. The first one over here is square root of 6x plus 19 minus, plug in 5 in here, f of a is going to be 1 over 30 plus 19, it's 49, square root of 49, 1 over 7 over x minus 5 as x approaches 5, right? And then the other one is going to be h approaches 0 of 1 over 6 times 5 plus h plus 19 minus 1 over 7 over h. As soon as I look at this, I remember that the form is going to be 0 over 0, and I see square roots, and it feels like I have to do very quickly multiply by conjugate, and it seems like what is under that square root is really handful. So I'm going to stay away from that one and instead continue using this one, and they are equivalent. That would be just messier basically. And I've done this type, and you see some of my work, I use that to see, for you guys to see how messy it gets and how quickly. And then sometimes that is the only method that can be used, but for most of this type of questions, really we can use either one of them. So now, what do I do with that? First of all, I know that there's a square root. I want to get rid of it because I want to find that x minus 5. Create that x minus 5 in the numerator so I can get rid of the 0 over 0. But to do that, first I have to do the common denominator. I have to simplify. And so the common denominator would give me this. Then I realized, oh, I don't like the fraction over fraction, so I get rid of the fraction over fraction. And and 7 times x minus 5 times it, and I'm changing the order because some ways are easier to see and it's less messy. If I had x minus 5 at the end or beginning, it would have been more messier. That's why I put it in there. And now I can multiply by that 7 plus square root of 6x plus 19 and 7 plus square root of 6x plus 19. And then the numerator becomes, limit as x approaches 5, numerator becomes 49 minus big parentheses 6x plus 19, and the denominator is 7x minus 5 square root of 6x plus 19 times 7 plus square root of 6x plus 19. Right? Oh, this is big. Imagine just having that h instead of x. So 5 plus h instead of x everywhere here. How big and messy that would be. So now, limit as x approaches 5, I need to clean up. This is going to be basically negative 6x minus 19. 49 minus 19 is 30 minus 6x. Oh, by the way, 30 minus 6x is going to be 6. That's not 6x. 6x is going to be 6 times 5 minus x. And denominator 7x minus 5 times square root of 6x plus 19 times 7 plus square root of 6x plus 19. And now these two simplify with a negative sign, because that's 5 minus x is negative x minus 5. And what is left is going to be limit as x approaches 5 of negative 6 over 7 square root of 6x plus 19 and 7 plus square root of 6x plus 19. So we accomplished that part that we knew that x minus 5 has to be simplified from the denominator, and that happened, and now it's not a 0 over 0 anymore. And so what you do is at this point I can plug in. So when I plug in, I get negative 6, 7, square root of 6 times 5 plus 19 times 7 plus square root of 6 times 5 plus 19 is 49. And clean this up. Negative 6. This is 6 times 5 plus 19, which was 7. 7 times 7 times 7 plus 7, that is 14. So, and this is going to be the, basically the, this is going to be the derivative. And it simplifies a little bit. 6 and 14 simplified by 2, and so negative 3 over 7 to power 3 is the answer. Now, can we get the same results by using the derivative formulas? So what we do is we take the derivative of this using our formulas. What formula would work for this one? This is basically bring it up. It's going to be it's basically f of x is 6x plus 19 to power 1/2. Bring it up, and it would be 6x plus 19 to power negative 1/2, and that is a chain rule. And so I find the derivative of that, negative 1/2 times. The derivative of outside is negative 1/2. The inside to power 1 less. What's negative 1/2 minus 1? It's negative 3/2. Then derivative of inside, which is a 6. And so I get negative 3 times 6x plus 19 to power negative 3/2. Now, again, this was supposed to be found at f of 5, right? So plug in 5, negative 3, 6 times 5 plus 19 to power negative 3/2. It would be negative 3 times, again, 49 in here, times 49 to power negative 3/2. That is the square root of 49, negative 3 times 7 to power negative 3. It is negative 3 over 7 to power 3, and it checks out.